বলরাম আছো? বলরাম। হ্যালো, হ্যালো।
App visible. হ্যাঁ, দেখা যাচ্ছে। এবার অসীমের স্ক্রিন দেখা যাচ্ছে। না, তোমার স্ক্রিন আসছে না। অসীম প্রেজেন্ট করছে তো তোমার স্ক্রিন কি করে আসবে? তাহলে তোমার মানে তুমি তো এখানে দাঁড়াও, তাহলে আমাকে আমারটাতে করে রাখতে হবে, তোমাকে তোমারটাতে করে রাখতে হবে, এইভাবে হবে। বলো বলো। এই যে আবার একটা ফোন করবো। আচ্ছা, বলো।
বলো। হ্যাঁ। আচ্ছা আচ্ছা আচ্ছা, ঠিক আছে ঠিক আছে। ঠিক আছে ঠিক আছে ঠিক আছে, হ্যাঁ হ্যাঁ। ঠিক আছে ঠিক আছে ঠিক আছে, হ্যাঁ 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 হ্যাঁ। হুম। We are waiting for few more participants to join. Thank you. Well, we will resume in few minutes. Waiting for few more participants to join. In few minutes we'll join. Thank you. শব্দ চলবে না, আজকে মাইক অন থাকে। Hello, hello, mic testing, hello. Hello, hello, mic testing, hello. Waiting for 1 minute, last 1 minute to join few more. Well, good afternoon, everyone. Welcome to RTIC 2020 in the fourth day. We are welcome you all to this workshop. As per the schedule, we have a lecture session right now. It's a special session by Dr. Songita Roy from Thapar University. But due to some technical issue in her area, we are not right now able to connect Dr. Roy. However, we will start our hands-on session right now, and when she will join us, we will continue with her session in the next part of our today's session. Well, so what we have planned today is to start with where yesterday Mr. Asim Kumar Panda left. We just will begin from that part, and then we'll continue with some more experiments, right? So welcome you all to the fourth day. Thank you all. Well, over to Asim Kumar Panda. Thank you.
Thank you, Balaranga, for your nice introduction. And I want to thank all the participants for joining the session. So today I will present a hands-on session on node-MCU connectivity with cloud platforms. So in the yesterday session, I talked about the intranet connectivity with node-MCU, and today I will speak about internet connectivity. So right now I will present on the internet connectivity with node-MCU. So today I will try to explore these points. First, Google Firebase Cloud Database. Next, node-MCU connectivity with Firebase database. And third one, data access from Firebase database. And next, introduction to Thinker.io open source IoT platform. Next, node-MCU Thinker.io connectivity. After that, a little bit introduction to IFTTT, and then how to analyze the IoT data. So this is the last part that I will cover. Okay, so these are the points I will discuss today, try to discuss within the time frame. So, without wasting any further time, let's move to the content. I think that will be the good approach. So, okay, before starting the session, I want to discuss some points with all the participants. I know that many students are also participants, so they want that, okay, from the scratch, if they can develop the IoT applications, right? So I think in this workshop we have done that how to start from the beginning. Suppose I don't know anything about the hardware kits, components, sensors, and also the internet connectivity, then how I will proceed. But I want to develop some IoT devices. So for them, I think it is the best way to start. Okay, and we are exploring those components also. And at the same time, we will cover the advanced topics also, like the cloud and database connectivity with node-MCU. So those points are also there. So it will be a mix. Those who are yet to start their application in IoT, they can also learn from this, and for others also, they can advance their own development. So let us start with the Google Firebase database. Okay, so now I think in the previous hands-on session, you can explore one thing, that all the applications are available only at home. At home means internet, within internet. So if there is no internet connection, you can't access that. Okay, suppose you want to switch on or switch off your AC before coming to your home, then how to do this? Suppose right now there is a scorching heat outside, so too much hot and humid condition. So whenever you want to reach your home, you want a cool atmosphere. Okay, If you are able to on your AC before, they say 30 minutes or 25 minutes before your arrival, then I think the atmosphere will be cool. Okay, and you don't have to wait, right? So how to do that? So without internet connectivity we can't do that. Okay, so for that we want that internet connectivity, and that's why we need some servers where we can deploy the data and we can access that data from outside our home. So not only from our home, we can access that data throughout our universe. Okay, maybe you are in America, maybe you are in Australia, anywhere you can access that data and that application also. So right now, today we will explore that. So for that, one component is very much important, that is the cloud database. If you want to do this kind of applications, you have to store the data over cloud database so that you can control and access the data from anywhere in the world. Okay, so this is the Google Firebase, a normal architecture actually. That this is the node MCU. So the node MCU will transmit the data to the through the internet to the web cloud database. Okay, here it is Firebase, this one. And next, the web application or maybe mobile application, both the applications will fetch the data through internet from the Firebase. So there will be no link between, direct link between the node MCU and the web application or mobile application. So the entire thing is wireless, and obviously the data it will fetch, the applications will fetch from the cloud database. Okay, so this is the architecture we will follow to develop our applications. Okay, so let's explore the Firebase database. So for that, I want to shift my presentation mode. So right now, what I will do, I will go to the Google Firebase website where we can access and explore all the functionalities. Those are essential for us to develop our application. So first of all, we will go to the Google Firebase database. So wait for a few seconds, and after that we will move to our database activity that is available in Google Firebase. I think the browser is visible to all of you. Can you see the Firebase console? Okay, okay, thank you. So what you have to do for Firebase, you have to log in using your Gmail. So obviously it's a Google product, so obviously you have to use your Gmail account, and after that what you have to do, you have to do your project, right? So for that you have to go to the add project option. So here some of the projects are already created by me, so I will not explore those projects right now. Later I will show you during the demonstration one of the project that I have created. So right now, how to create the project? Okay, so for that, what we will do, go to the add project. So here just you give your own name. So it is it depends on you what name you want to do. So right now I want to add test. So this is the test IoT project name, and the project name must be must consist 4 alphabets. Okay, minimum 4. So right now this is the unique identifier, because we need this identifier later in our coding. Okay, so we have to remember this one. Later obviously when you explore the platform you will have this identifier, so no problem right now. What I will do right now, I will continue with the name. So after that he will ask you about the Google Analytics if you want to add to your Firebase project. So no problem, we will add this. So let us continue with this. Next, select an account. Obviously you can choose the default account for Firebase, or maybe you can create. So I will go with the just default account. Next, then just click on the create project, and it will take a couple of seconds to create the project, and the project name is test IoT. So it will take some time depending on your network connection, and within minute I think it will complete the entire procedure. and next you will have our project. Okay, so test IoT is complete right now, and we can continue. Fine. So this is the console we have in Firebase right now. Okay, and okay, here few parameters are available. Those we have to note down for our coding also, because we have to code our node MCU in Arduino IDE. Okay, so those parameters we have to take care, right? So I will explore those parameters obviously first. After that, we will go to the Arduino IDE for the programming part, where we will upload the programming part to my Node MCU board so that it can communicate with the Firebase database. So first of all, what I will do, I will go to the project overview option here in the settings. Okay, and then I will go to the users and permissions. Fine. So here we have so here this is the owner. Okay, so who is the owner of the database? So here we will go to the service accounts. Now this is very critical because you have to note down these service account parameters, and that is the database secret. So whenever you have to code your Node MCU, right? So this parameter is very much essential for coding your Node MCU. Otherwise, you are unable to connect to your Firebase database. Okay, so click on the database secret, and after that, obviously it will give you the code, secret code. Okay, if you click on the show, then obviously it will show you the code and you can copy. Okay, so after that you have to copy. And what is the database name? That is the test IoT and -6AC41. Okay, so this is the database name and this is the secret code. So we have to note down this secret code for our coding implementation part that we will do in our Node MCU. Fine. So this is the thing we have to do in setting, and after that we will go to the database option because we are dealing with the database. Now in Firebase lots of options are available. We will not explore all those things because the time will not permit us. Fine. So what is the main component here that we will use? That is the database component. So I will try to focus my activity on the database point. Okay, so click on the database point, and okay, so right now we will have our database that is available under test IoT project. Okay, so we have to create the database. Fine. So here you will have the option to create the database. So let's create the database. And yeah, two modes are there. You can start in production mode and also in test mode that you want to test your project. Okay, fine. So this will be available for 30 days. Fine. And one thing you have to know, this is a free account. So if you want to develop your application, own application, private applications, then it is good because the free account is enough for that. But if you want to start for your business, then it is not enough. Then you have to purchase. Obviously, Google is there not for free. Okay, so you have to purchase the premium plans from Google so that you can upload more data and there will be no restrictions, right? So right now I am using for my private application, so I don't want to purchase any plan. Fine. So start in test mode. So next we will go to the next option. Okay, so here you have to set the location. You can choose any location here. So I think you choose the Asia South, maybe that is nearby to our location. I don't know, but let's choose anything. So South one, and then we will move to the next. So right now it will create our database that we want. Okay, to communicate with our Node MCU. So the Node MCU will be able to store the data in Firebase database. Okay, so again it will take some time, not more than 1 minute, I think, and within that it will configure the database for us. And another important parameter we have to note down. Actually, that parameter is also essential for the Node MCU coding. Basically, we need two parameters. One is the secret key that is available in the setting option, and another one is the database name or URL. Okay, so that thing we have to put in our Node MCU coding also. So here one thing we will do, that is the rule. So you have to define the rules. Fine. the rules for database writing. Suppose the third-party applications want to just modify or read your data. So if you don't set your rule, maybe anyone with the connectivity can access your data and read and write operations on your data. So that will be critical for your applications. So that is not desirable. So for that, we will just update the rules for us. So now two options are here. Cloud first in the Cloud Firestore option. One is real-time database, another is Cloud Firestore. So we will go to the real-time database. Okay, that means the data will be available all the time whenever we want. Now this is the URL actually. This is the URL we want for our NodeMCU coding. So this URL you have to note it down. Okay, this is the URL. Fine. After that, what we will do? We can also add the parameters here. Suppose two parameters are here. In this demonstration, I want to show you how we can upload the humidity and temperature data to our Firebase database. Okay, so let us add two parameters. One will be maybe humidity and another one. So what is the default value? Say 0.0. Okay, fine. Next, what we will do? We will add. Okay, next again we can add another parameter. For that, what we have to do? Maybe say temperature. Okay, so let's write temp, and the value is say obviously initial value 0.0. So just hit enter. It will add both the parameters. Fine. So later when your NodeMCU will connect with the Firebase database, it will update the data. Fine. So two parameters already we explored. One is the secret, database secret, that you have to note down. Another one is the URL. Next, what we will explore? We will explore the rules. Fine. So here we have to edit the rules. Now this is the rule section where you have to modify. So right now, what is the default read and write parameters? Those are available here. False. That means nobody can access the database without permission. Okay, the third party can't access it. Fine. So what I will do so that the third party applications can modify and read, that means override the data. So whenever NodeMCU will send the data will override the previous one. So for that, what I will do, instead of writing true false, I will write true, so that the third party application can modify the data and also it can read the data. Okay, so this is very much simple. I think just you have to make it true so that the third party application can access the data. After this, just you have to save this one. Okay, for that go to the publish option and it will store it. Okay, so right now if you export the rules, automatically it is in true mode. That means the third party applications can read and write data from the Firebase database. Okay, so this is the technical part that we have to do in our Google Firebase. Fine. So next, what we will do? Next, I think we have to go to the Arduino IDE, right? And where we can explore our codes, and then we will upload the data, right? Then we will upload the data from NodeMCU to our Firebase database. Fine. So right now, what I will do, I will stop my presentation for this, and I will go to the Arduino IDE. I think that will be the most suitable platform right now to explore that how to do the Arduino coding. Fine. So let us go to the Arduino coding. And I think it is easy enough. I think we can access it. Okay, and we can do all the activities in our Arduino IDE. So right now, okay, we will have this one. So right now I will share the Firebase Arduino IDE where I have where I will upload the code, and I will just show you the output also. So let us yeah, so right now it is visible, I think. Okay, all of you can view the Arduino IDE. So right now I will zoom it so that all of you can view the code. Okay, so right now it is okay. Can you view the code? Is it visible to all? Okay, okay. So what I will do, wait for few seconds. Okay, so I will zoom it a little bit more so that everybody can visualize it. Okay, so right now I think it is okay, and you people can visualize it. Okay, fine. So yeah, this is the code actually we will run in our node MCU. So maybe a little bit complex compared to the previous codes, right? Because obviously we are going to the complex applications, right? From the standalone IoT devices to the internet-based devices. After that, right now we are exploring the internet one. So obviously we are moving to the complex devices and applications. So obviously the code will be a little bit more complex compared to the previous ones. Okay, but I think it is manageable. All of you can manage it. Once you explore the platforms, when you explore the Arduino IDE and all the technical parameters, obviously I think it is not so tough and difficult to do the coding. Okay, and obviously in internet you will have lots of help to do it in GitHub, and many other websites are available where lots of I think enthusiasts are uploading their help, their code and all those things. So obviously ready-made things are not available, but help will be there, and you can customize that depending on your hardware components and platform. So help will be there. It's not that nothing is there and you have to then do all those things and you don't know anything about it. So help will be there, and yeah, if you explore from the basic step by step, then I think you can easily explore all the things and you can develop the applications. Fine. So let us explore the code. So for that, we have to include the header file, that is a Firebase ESP8266.h, and after that ESP8266 Wi-Fi.h. So these are the header files, very important. After that DHT.h. Now this Firebase ESP8266Y, because we want to communicate from our node MCU having ESP8266 with the Firebase. These header file will define all the technical parameters. Those are required to do that connection. Fine. After that, obviously for the Wi-Fi connectivity, we require this one. I want to highlight this one. So this one is the header file that is we have to use, and after that this one DHT.h. So for what we are using this? Because we have a DHT11 sensor. So right now I will demonstrate you the application where we will send the DHT11 data. That means we will fetch the temperature and humidity data from our environment and upload that data to our Firebase database. So that is the activity we'll do. So for managing the DHT activity, we will use this DHT.h header file. Now before that, before proceeding to the next part of the code, what we have to do, we need some library files actually. Those we want to include, otherwise it is not possible to run this code. Okay, because these header files are not easily available. The first one, file is ESP8266.h. So for this, what we have to do, we have to go to the tool option and manage libraries. Okay, so these things we have to manage, and in the our library manager, you have to search for. Yes, I already did these things in the previous session also. So you have to search for like DHT. Okay, so DHT, if you go for DHT, automatically it will give you all the libraries. Those are available under DHT. So this is the DHT library, sensor library. Okay, so already installed in my system. Now when you will start this application, you have to install this one. Okay, fine. And again the ESP8266 one also you have to install. Okay, so lots of header file things are available. Those you have to install before proceeding to the uploading of code. Okay, next, Firebase host. Now, in the previous Firebase website, we have explored 3 parameters actually, right? So one of them is the URL that we have already explored, right? So this is the URL. And remember one thing, without the HTTP and other option, so you don't include that, only the, okay, only this, without any HTTP. Fine. So this is the Firebase host, and after that, authentication part. So that is the secret code actually. Whatever secret code you have in your database, that means in the setting options, right? You have to note down that, and you have to write that secret code here, so that actually these two are for integrating your NodeMCU to the Firebase. So whenever NodeMCU will try to communicate with the Firebase, it will use these two. So automatically it will link to your concerned project, okay, your concerned account. So that is the thing. Okay, for this we need these 2 parameters. Fine. Next, Wi-Fi SSID. So here you have to mention your Wi-Fi hotspot, whatever name you have. Okay, after that the password. So through this Wi-Fi actually NodeMCU will connect with the internet. If your Wi-Fi is available at your home with internet facility, then it can connect, otherwise it is not possible. Okay, then otherwise you can't connect with the Firebase. So you have to use the Wi-Fi hotspot name or Wi-Fi name here, and with the password. Fine. Next, what I am doing, DHT pin 2. Okay, again I am using the normal general GPIO pin. Okay, so you can use also the D2 pin of NodeMCU. Okay, now these two are not equivalent actually. So these two are not equivalent. So don't confuse with the GPIO pin with the NodeMCU pin. Fine. Next, what I am doing, okay, I have to control one LED also. Fine. So not only data actually. So right now, what we will do, using our app, everybody can control the LED. So right now at my home, right now I have the LED bulb, and if you have the app that is available with me, if I will share the app with you, all of you, and if you use that app, automatically you can control the light actually. So you can control the light that is available at my drawing room right now. Okay, so that LED bulb is connected with the GPIO pin 5. Okay, so that is not D5. I have written these things so that you people will. It is normal that sometimes I me also that I confuse with the GPIO and NodeMCU pin, right? So that's why whenever you have to use the D2, that is NodeMCU pin, write D2. Okay, D. So in front of the number, write D. And again, in case of GPIO, just write the number. So that will differentiate between these two. Okay, because most of the time during my first IoT experience, that was the big problem. Okay, so this is the thing. Fine. So next, what we have to do? Okay, Firebase data. Actually, we will define the Firebase data and LED data. Okay, these will be the Firebase data object. That's why we need the header file, Firebase ESP8266.h. Next, JSON format. So it will store the data, transmit the data in JSON format. Next, void setup. Okay, so we will begin the communication with serial.begin with the baud rate 9600. Right. So I think lots of codings are available in this application. So I will try to quickly go through each of the lines so that we can move forward to the demonstration or application part. And I will obviously share the coding with all of you if you are interested to develop the IoT applications. So next, what we will do, okay, this is the Wi-Fi.begin. It will try to connect your Wi-Fi, that means NodeMCU, with your Wi-Fi system. And if it is connected, then it will print just normal. Next is a delay. Okay, next it will show you the IP. Fine. So next, this is the important thing. What we will do? So here 2 variables are there. Actually 3 variables are there of floating type. So H that is for humidity, T for temperature, and F for again temperature, but for Fahrenheit. So one thing is that whenever we will write dht.read humidity, it will read the humidity value from the DHT11 sensor. Fine, and that's why dht.h. So this function is available in the dht.h header file that we already explored in our code. Okay, so this is the dht.h that will be responsible for this function. And okay, this one. And next, in variable t, we will have the read temperature. So automatically it will read the temperature from the environment. Next, what we will do, obviously we will read the temperature again for Fahrenheit mode. And if there is no data available, then it will show you the error that okay, failed to read from DHT sensor. So the system is unable to fetch the data. Okay, fine. Next, we will print some data and we will send the data, okay, to the Firebase. So this is the function where we will send the data. Okay, Firebase data. So this is the Firebase object, data object, and next the URL actually. Okay, okay, fine. Next, okay, in the loop section we will do this one, and we will control our LED here in the loop section. So if LED dot data string data equals to 1, if 1 will be sent through the application, then it will be high, the LED will be on, otherwise the LED will be low. So this is the Arduino code we will have for our application. And what we will do, we will run the application, okay, in the Node.mcu. So right now this is the complete code. What we will do, we will run the code. So for that, upload. So this is already uploaded in my Node.mcu code. So what I will do, I will quickly go to the app actually that is available with me for connecting the Node.mcu with the Google Firebase. Okay, so let's have the application. Okay, that through that we can just control our LED bulb, right? So I will stop it right now and I will go to the application part. So for that, what I will do, I will go to my MIT App Inventor 2. So this one, I think, yeah, right now it is available. Okay, so this is the app actually. This is the app that is through which we will actually communicate with our device, Node.mcu. Nothing is there actually. Few buttons are there. Okay, and so these two are the buttons, one for on, another one for off, and it will read the temperature and humidity. Okay, so we will go to the design option. Okay, so in the right hand side you can view the components actually. So lots of labels are there for writing the label, like this one, temperature, humidity, those things. And after that we use just two buttons, one for on, another one for off. Okay, so these two are critical. And again, another thing you have to add, so that is missing in the previous part, that is the database. Okay, so we have to add the database with our Android application, right? So right now for that, what we will do, we will go to the data connectivity. Fine, so storage. Now in the storage you don't have the Firebase database, because right now MIT App Inventor we have CloudDB, file, normal file, TinyDB and TinyWareDB. Okay, these four options are available. Then how we will add our Google Firebase database? In MIT App Inventor we have the option. So right now they are providing us the facility of integrating Firebase DB as experimental purpose. We don't know when they will stop it. Maybe they, in future, maybe they can continue with the Firebase DB, or maybe they will stop it. But no problem. Right now we have this one, so we will use this one. And fine. So we have to add this Firebase database. So right now this is already added to my application. Okay. So this is the Firebase DB. Now this is the component we have to modify actually. We have to configure. So what we will do, we will just click on the Firebase DB. So I think all of you remember two parameters. Those we have already, those we have with us in Node.mcu coding also. The first one is the Firebase token, that is the access code or the database secret code. So that secret code you have to put in your MIT App Inventor Firebase database. At the same time, you have to add that one in your Node.mcu coding. After that, what you have to do, you have to paste the URL. So here, complete URL. Okay, don't remove the HTTPS, these things, backslash. Okay, you have to write down the complete Firebase URL. So these two parameters are essential. Fine. One is the secret code, another one is the files URL. Then we are ready to go. Okay. So we are ready to go with our app. So next, I think all of you know how to develop the code, how to test the code. Fine. So for that, what we will do, just we will go to the build option and then we will choose any of these. One for the QR code. If you want to scan your QR code through your smartphone, you can able to download the APK. Otherwise, you can save it and later transfer to your smartphone. So right now, I think okay. What we will do, I will just switch on my web camera so that it can focus on the kit with the LED bulb that is associated with the node MCU, and okay, so that it can give you the visualization that okay, whether the LED bulb is rightly working or not. So for that, what I will do, I will just go to the webcam view. So right now I will stop this one, the MIT App Inventor 2 screen, and I will go to my Android webcam view. So before that, it will take a couple of seconds to configure the app actually, and at the same time we have to plug the main connection. So wait for a few seconds. Until that, you can go to the logic blocks actually and can visualize the code. Okay. So actually, why I like MIT App Inventor 2, that is the main thing. It is actually very much easy for me actually. Okay. And I don't have to spend too much time, that I already told in the previous section, previous hands-on session. And another thing is drag and drop. So I like it. The features MIT App Inventor 2 is giving to its users, that is very much I think interesting. At the same time, I don't have to install. So that thing is there. I don't have to install it in my PC and configure all those things, because at the same time you can't do all the things. If you want to configure your IoT platform, at the same time the Arduino code in Node MCU, and at the same time if you want to do the Android application also, that is not possible. So we have to focus on one actually. So if you want to develop some application for commercial purpose also, it is better to have some group. Okay, so make a group and maybe 3 to 4 people will be there, and someone will take care of the application part, someone will take care of the IoT, that means the backend part, the server part, someone will with the Node MCU coding. So then it will be good. So for one, it will be a hectic job if you want to do all those things. So right now, in my case, Node MCU, I think best for me, and also the MIT App Inventor 2, and that's why I want to choose this one, and that is the reason actually. So the main thing is that we can develop it. Okay, so right now I will just give you the webcam view that is available with me. So I will stop this MIT App Inventor 2 right now, and I will go to the webcam view. So just 3 to 4 seconds. After that, I think you can will be able to view the demonstration. So okay, so I think the entire components are visible to all of you. Is it visible to all of you? Okay, thank you. So yeah, so at the same time, I think I have to show you the app actually. Okay, whether I am doing this from internet, because you can't see me. Okay, so I can do anything. Fine. So for that, what I will do, I will show you my coding also at the same time. Another point. Okay, so let's have a quick look on the app that is available in my smartphone. So I think this is okay. Fine. I will do this thing. Wait for 1 second. Then I think it will be easy for me to show you the app. So lots of tabs are there, so I have to switch over them. Fine. So it will take a couple of seconds actually. So right now I think the app is visible to all of you. right? So you can view the temperature and humidity that is available right now at my home. Okay, so what I will do right now, I will just switch on the, okay, it is very much difficult for me to show you both the things, right? So yeah, again it is fine, I think. Okay, so let's switch on the valve. So there is a delay. So obviously that's why it will take some time to switch on the valve. I have put that delay intentionally because sometimes there is too much fluctuation. So to cope with that, we have to put the delay. You can customize it for your own purpose. So right now it is on. So what I will do, I will just switch off it. So again, it will take some time and switch off. And again, one interesting point, it is available. That means the temperature and humidity, both the data are available. So you can visualize the temperature and humidity also. So right now I will try to put the camera screen, my application screen in front of the camera so that you can visualize it. Okay. Better. Right now the demo is complete. So right now what I want to do. Okay, the APK is available. So I will request Mr. Balaram Ghosal, so that he can share the APK with all the participants. So why not we have a live demo, right? So the bulb is here at my home. So you are maybe from throughout. Okay, the participants are from all over India, right? Maybe someone is from Kerala, someone is from Rajasthan, right? So I am right now in Kolkata. So you right now, what is the benefit? Why we have to do so much activity for this? What will be the benefit? So right now, maybe you are in USA or you are in Kashmir or you are in Kerala. You can control my LED light with the help of the app that is already available. Okay, with me also. And so, do you want to test it? So at first, I will request Balaram to please share if he can share his screen with the app, and obviously at the same time I will request him to switch on the light, and at the same time if he can get the temperature and humidity value from the app also. So over to Balaram to please share the screen if it is possible and turn on the LED. Okay, so over to Balaram.
Yeah, thank you, Asim. Well, I have installed the app just shared by Asim Kumar Panda to me. Thank you, Asim, for sharing the app. Okay, I'm going to present the app from my mobile phone. Well, yeah, here I'm going to present the window. Okay, when I will share my window, actually Asim's window will be switch up automatically. This is a drawback in GTalk. However, we will switch it again. No problem. Yeah. So I am sharing the window now. Yeah. Here is my screen visible to everyone?
Yes, it is visible.
Well, fine. Yeah. You can see the app sent by Asim to me is Node MCU. Here it is. It is already shown by Asim, right? Now, what I'm doing, I'm just switching on the light. By the way, you can see the temperature. It is 33.9 degree Celsius. I just see, I can see this in from my mobile phone. And the humidity, actually what the scenario is, I'm outside of my home and I'm checking my room temperature and the room humidity. Based on that, I'm going to switch off my AC. Okay, and the lights. Now I'm just switch on the light. Yeah. I think.
So I think simultaneous activity can't be shown here actually, because both the screens are, I think, at the same time are not active.
Okay, by the way, what we are doing, we are making this visible in this thing visible, both the window in YouTube. Well, so if you see the, well, uh,
And okay,
just wait for a few seconds. I'm just going to share this in YouTube. In YouTube, it is possible to view both the window. Well, uh, yeah, yeah. Those who are watching in YouTube, I think it is now visible to them. And what I'm doing, I'm just, yeah, I'm just switching on the light.
so it will take couple of seconds actually, because one delay factor is there.
Yeah.
So that's why it will take some time. Otherwise, if you don't put the delay, then automatically it will work. Okay.
Well, Asim, will you please tell me what is the present condition of the light? It's burning or not?
I think no, it's not on. It is in off mode. Okay. So just you refresh the app. Yeah,
Yeah,
right now it is on.
it's
You
on.
can visualize. Yeah.
Well, everyone can.
Actually,
Well, I just press the power on button in the light present inside somewhere in
okay.
Kolkata. Over
Better,
to
better.
Asim, please.
Yeah. Again, Balamda, just you share your screen. Right now, I will switch on my camera so that in case of Gmeet also, the viewer can check the output. Okay, so that will be good, because in Gmeet right now my presentation is off, so nobody can check that camera view. So let's put my camera view. Okay, and wait for
No, I'm
few seconds.
asking to everyone: is this in Gmeet? Is it is both the screen available to you?
No, in YouTube we can see both the screens.
No, no. In Gmeet.
Uh, in Gmail,
Yes, sir. As individual screen, it is present.
Yes. You can just pin on my camera.
yes,
Okay, whatever it is showing. I think it is visible.
now we can see.
Yeah, very good.
Okay.
So I'm just switching off the light by pressing in my mobile phone. Yeah, I just pressed and it should be off in few seconds.
Yes, it is off. So all of you can visualize that live event.
Again, I'm turning it on. In few seconds, it should on. Yeah, it's on. And now I'm switching it off. Okay. Fine. Fine. I think Asim, it's working fine with this app with your setup. Well, over to you. Thank you.
Okay, thank you, Bolaramda, for the demonstration part. I think, and so I think it is clear to all of you that we can manage it, right? We can manage our appliances throughout the world. From anywhere, we can just control our device. So, and again, the purpose, right? So, what is the purpose behind this? So, again, I will say the same word as Balaramda said, that yeah, our humidity and temperature, okay, whatever temperature humidity we have, that will control our AC settings, right? So if we can control, we can have the inputs from our environment, that okay, right now this is the humidity and this is the temperature from the environment. We can easily automate, right? So that is the thing. Using this data, we can easily control it, and we can easily modify it. So it is possible. It is very much possible, and the cost factor very less. So suppose right now, if you want to purchase a smart AC, and that is also available from the leading MNCs, then what is the difference between a normal AC and a smart AC? I I think for this you have to spend 5 to 7,000 more on the smart AC, right? So that is the thing. If we can, and at the same time, the customization is not available. You have to depend on the third-party server, third-party applications. So they can, whatever they will develop, you have to take that one. So no customization is available, right? So they will not integrate your fan with the AC. But using your own app, you can integrate your fan also with the AC, right? So again, there is another part that I left actually. Okay, we have configured the Firebase database, right? So let's go to that Firebase database and see the activity, what is going on there. So right now you can visualize the data. Okay, so right now what I will do, I will present.
Well,
Okay,
Asim, I'm interrupting you.
Yeah.
Actually, should I share the app to the participants? I think it will.
Yes. You can share that with the participants, but right now I think they can't visualize it because I will
Exactly.
shift my window actually to the Firebase, Google Firebase. But at the end of the session, if they want to experiment with the app, no problem. I will share my webcam view with them, and at the same time they can use the app and they can control the LED. So that is welcome. Okay, no problem. They
Okay,
can
okay,
control my LED.
okay. Thank you.
Okay.
Yeah.
Okay. So I will request Avalanda to stop the screen sharing. Okay, thank you.
Yeah, welcome.
Okay, so what we have to do right now, we will go to the Google Firebase, right? So, okay, so go to the Google Firebase and yeah, the Firebase system, yeah, this is. So I think right now it is available to all of you. Can you visualize the Firebase console? Is it available to you?
Yes, it is available.
Okay,
Yes.
thank you. So what I will do, I will go to my database that is connected with the node MCU, right? So this is the IoT test project and the database is available here. With that, the node MCU is connected. So this is the real-time database. And okay, so let's have a look on the database activity. Okay, so here you can see the LED value is zero because it is off. And right now we can have the humidity value 75 and the temperature value is 34. Right now it is changing. Okay, so I have given a delay of maybe 7 seconds to 10 seconds, maybe. I don't remember right now. So depending on that delay, it will change. Okay, so modify the delay and you can have your live data on Firebase and you can control it throughout throughout any location. Okay, so that's it. And using this Firebase, you can control your LED bulb and all the home appliances if you want to connect. Obviously, for free account, some restrictions are there. That obviously for free things we can manage. I think we don't want everything in free. Okay, so if Google is giving some free, then why not? We will use it. And obviously for business purpose, I will say, or commercial purpose, I will say develop your own platform. And there are other platforms; those are freely available, and obviously you can customize that. One of them is Heroku, and other platforms are also available. So you can explore those platforms. Okay, and those are very much active actually. Okay, so you can shift your entire activity in those. So right now I this is the humidity data. If I want to just focus on the humidity part. Okay, so this is the complete activity. That means complete IoT based, cloud based IoT applications, right? So okay, I will stop right now. I will stop the entire activity actually because some components are still I have to cover. So I want to take some questions if the user have any doubt or query during for this application. Okay, because I got some comments in yesterday session that the activity interactive session should be more interaction should be more. Sorry for that. Actually, this is the online session, so we can't have that level of interaction with the participants. Otherwise, it will be problematic for us to conduct the intersession. But right now, I have completed my first demonstration, so I can take queries and doubts from the participants if they wish to. So I will wait for a few minutes if participants have some query or any doubt. So over to Balramda, if any participants or basically from the students, if they have any query. Okay.
Sir, I have a question.
Yeah.
Achha, sir, why did you set the rules in the true mode? I mean, no one else manipulated the code.
Yeah.
No. I mean, in this context, why did you just change the rules?
Yeah, actually, if you spread it false, that means nobody can access it. It is for third-party access. Okay, these rules are for third-party access. So if you want to set it in false, that means nobody can access the read and write option. That means the node MCU is sending the data to the Firebase. Actually, it is writing the data on database, right? And also the MIT App Inventor 2, that means the application we are using, the Android application, that is reading
Yes,
the
sir.
data. Okay, so if you put false in both the cases, read and write, automatically it will deny all the access. Okay, so that's why we have to put true, so that the third
Okay,
party
sir.
applications, whatever we are using, they can access it. Okay.
Okay, sir. Okay, sir. Thank you, sir. Achha, sir, if the app that you created using the MIT that application thing, why is it considered as a third party? I mean, is there any platform from Google where you can create app which will not treat it as a third party application?
Actually, if you want to develop, actually, one thing is there. Whatever applications you will use, everything is third party actually. So, and
Oh,
if you
sir.
want to use everything from Google, then it is not possible to customize it, right? So,
Oh,
anything
yes,
you
sir.
want to
Yes, sir.
use, then it is obviously the third parties are based. Okay. Yeah.
Okay, sir. So this means that we have to always set the rules in true mode.
Yeah. Obviously, you have to set it
Okay,
in
sir.
true mode.
Okay, sir. Oh, sir. Thank you, sir. Thank you, sir. Sir,
Sir,
okay, sir. Yeah, wait, carry
Yes.
on,
Yes.
carry on.
sir, if I used this app from my house, then the temperature and humidity showed in the app. This is the temperature and humidity of your house or my house.
Obviously, my house, because the sensor is available at my home, the LED bulb is
Ah,
available at my
okay,
home, so obviously
okay,
it will fetch the data from my home. Okay.
okay. Thank you, sir.
Okay, welcome.
Okay, sir. Sir, I have another question.
So kindly, can you give your introduction, please, if you don't
Yes, sir.
mind?
Yes, sir. Sir,
Okay.
I'm Shudip Topal. I study BCA at B. Poddar Institute of Management and
Okay.
Technology.
Okay. Okay.
Acha. Sir, my question is, sir, there is this delay time thing in the Arduino MCU. Sir, we can customize the value of the delay time thing, which means
Yeah.
that it has some purpose. So, what is the purpose of delay time, sir?
Actually, yes. All the resources I am using. Okay. Kindly switch
Yes, sir.
off your mic. Actually. Yeah.
Yes, sir. Sure.
Yeah. Fine. So actually, all here I am using all the third-party resources, and those are free, right? So in the free account, we have some limited access. So we can't overwhelm our resource. That means our infrastructure too much, right? So and there is no necessity at all, because if you want to send your temperature and humidity data without any delay, what is the purpose? Nothing. So if we want to see it after 5 minutes or 10 minutes, that is, I think, reasonable. What we will do with the per second data, I think there is no importance of that. And at the same time, I will save my resource also, right? So that is the purpose actually for giving the delay. Otherwise, you can use it without delay, no problem regarding that. Okay, but to save the free resources at the same time, if the data is not crucial for us, like if you want to get the webcam view, then that is obviously important that you should have all the strings. That means at that time no delay will be there, right? Delay is not desirable at that time. But in case of temperature and humidity data, I think it is very much reasonable to have the delay. Okay.
Yes, sir. Yes, sir. Thank you, sir.
Okay. Okay. Welcome.
Sir, I have another question, sir.
Okay. Carry on.
Sir, is there a way to configure the microcontroller such that when a particular temperature is achieved, the lights
Yes.
will turn on and off?
Obviously, it is very much
Yes.
possible. Very much possible. Just what you
Yes.
have to do, just put one. If okay, again, just mute your microphone
Yes.
actually.
Yes. 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 Yes.
Okay. Yeah, thank you. Just it is very much possible. You don't have to do any complex coding for that. What you have to do, just go to your Arduino coding and just put one logic that if temperature is greater than say 40 degrees Celsius. So if there is a too much hot and humid condition and you want to know the notifications, then okay, what you have to do? No problem. Just put that one. If temperature, okay, I will show you the Arduino code actually, and then I think it can be properly understandable. Okay, so I will go to the Arduino code also. So wait for few seconds. I will show you the code. Okay, this is the Arduino code. Fine. So here, we are reading the temperature or humidity maybe in the variable age. So what we have to do, I think it is visible to all of you. So I will zoom it a little bit more. Just one line of code. Just add the if this one variable is t, or in case of temperature it is t greater than suppose 35. Okay, then you can put the what, the led in on mode. So for how to put the led on high, so just pin mode led comma high, that is the normal syntax you can do. Okay, fine. I think that
Yes,
will
sir.
do. Okay, so that will do your job, or you can use this one also. Okay,
Okay,
that
sir.
means
That was that simple.
yeah, very much simple. Just it's a normal C coding actually. If and else logic, you can, that is any kind of logic we can apply here. Okay, no problem. That you can embed with your Node MCU coding. Okay, welcome.
Thank you, sir. Thank you.
Okay. Okay, fine. So yeah, fine. So just too much lecture right now. So what we want to do, just watch this video. Okay, so it will give you a break actually. we can dim the light, we can change the light color and all those things using the RGB. So RGB LEDs are available. So if people want to develop the mood lighting, like one popular device is available from Philips also, Philips Hue, another one from Cisco, and obviously not from them. Lots of products are available, but we can develop those things at our home also. So for that, what you need just RGB LEDs, okay, and the lights. After that, you can good to go. You can change the color, you can do all those things. So maybe in future workshops we can demonstrate that also. So before that, before finishing my lecture, I want to show you an important actually platform, IoT platform for analyzing the data. That thing we have to do. So right now we are demonstrating the applications, okay, of IoT and cloud connectivity. Next, what I will do, I will show you this one, okay, the Thinker.io and this platform. So what I will do, I will connect my Node MCU with the Thinker.io platform, and obviously we want to analyze the data. So I will not take too much time because right now it is already on our over. So what I will do, I will change my Node MCU kit with the infrastructure that is connected with the Thinker.io. Meanwhile, you can go through the diagram actually. So this is the platform, and this is the third part. These are the third-party platforms, and what we will do from the data point of view, the Node MCU will just send the data. Okay, the Node MCU will send the data to the Thinker.io platform. Okay, so that is very much possible. And what Thinker.io will do, it will just analyze the data, and at the same time it can do various activities actually. Activity means it can do various actions actually depending on the input. Whatever inputs are available from the Node MCU, it can show you that input, and at the same time it will just initiate some actions on the basis of the data. So right now, just wait for a few seconds. Meanwhile, I will configure my data and also the kit. Okay, better I will switch to the Thinker.io platform. That will be best right now. So wait for 1 second. I will just show you the Thinker.io platform. Okay, so this is the cloud console actually we have in Thinker.io. So this is the interface. Okay, so this is the interface right now we have. Fine. So all of you can visualize this one actually. So I will not go into the deep of Thinker.io, how to configure it and how to do all the activities, right? So just I will show you the demonstration. Fine. And that is the thing. So right now I have connected my Node MCU with the Thinker.io platform, and that is visible here. So what I will do, I will go to the dashboard actually. So fine, this is the dashboard, and yes, I think yeah, I have created one dashboard with my account. So this is the dashboard I have in Thinker.io, and next you can visualize some data. Okay, I think right now the dashboard is visible to all of you, right? So what I have configured, I have taken the data from Node MCU to my Thinker.io platform. So all of you can just visualize the data. Is it visible to all of you? The humidity is changing actually, and the temperature is fixed. So that's why it is not changing, because the delay is very less. So within 10 second or 7 seconds delay, the temperature will not change, but here the humidity is changing. Fine. So you can check the live data actually, and in the technometer also you can have the data. So the what is the humidity? That is 36. Fine. And what is the temperature right now? Yeah. What is the temperature right now? It is 34. Okay. So you can visualize the data from the Thinker.io. So if you want to analyze the data, that is very much possible here. Okay. And this is the LED bulb on and off. So what right now I can do? Fine. I can do one thing, that is I will share the link with all of you. Okay, so in settings I will go to the settings, settings, and okay, share. So this is the link. Okay, so I will copy the link and I will try to paste the link in the Gmeet, and I will request Balaram sir to copy the link to, okay, copy the link to copy and paste the link in YouTube also, so that other participants who are available in YouTube can visualize the dashboard. So okay, first I have to save it, no problem. So right now what I will do, I will go to the Google Meet, and in the chat option I will post the link. I think okay, the link is available in Gmeet, so in chat window. So you people can click on that and can visualize the console, that is sorry, dashboard that is available with me. So I will request Mr. Balram Ghoshal to share the link with the participants in YouTube also, and other participants if they are willing to view the dashboard. Okay. So over to Balram. Yeah, actually right now the view, they can only view, they can't modify it actually. They can view the temperature and humidity data, and at the same time LED on off, but I have to configure the LED pins for that. So no problem, it will take a couple of seconds actually. So meanwhile they can enjoy the temperature and humidity data. There is no, that means they can view it. Okay, so it can be viewed from anywhere as the data is available in the cloud platform. Okay, so and user participants can say your comment in Google Gmeet also, if you can view it, or you are unable to view it. Otherwise, I can't get the actual scenario. Okay. If it is, if it is the dashboard is visible. Okay, so it is properly visible. Now again, one thing I will do, that means through that interface you can also control my LED. Okay, and that's why the LED switch is also there. Fine, so that is very much possible. You people can modify that one. Not modify actually, yeah, you can switch on and switch off the LED. That is possible, right? But otherwise it is not possible to modify the humidity and temperature data. Okay, yeah, LED is not connected actually. Yeah, that's why. So yeah, I can at the end of the session I can yeah, you people can have the link. So at the end of the session I can give you the data actually. Yeah, they can give you the demonstration. Okay. Actually, yeah, one LED is connected with my breadboard, not the LED bulb. So I will try to focus. Okay, fine. I will try to focus my camera on that LED that is visible on my board actually. So just wait. Okay, I will switch on my camera actually. So this is the LED actually. Yeah, I think someone is switching on the LED. So if you just switch it off and check the status. Okay, and by default I think there is one delay. One delay is there for 10 seconds. So it will take 10 seconds to respond to the input. Okay, so it will be switched off. Again, maybe lots of participants are doing that thing at the same time. Actually, the relay is not connected with this board. Actually, I have two boards actually, one for the previous demonstration, and right now this is for the thinker.io. So right now, yeah, right now it is off. You can visualize it. The LED is off. So yeah, you can do this thing, right? So these are the activities we can do with our IoT activity, and I think it is interesting. I don't know about the participants, but for me it is interesting, and lots of technologies we have to explore actually for this. So right now I will not go too much into this because few points are left. Actually, those are, I think those are very critical for IoT applications. Those are available in thinker.io. that you want to visualize. So quickly, I will go to the data buckets. That is very much important actually. So whatever data is coming, that will be stored in that data bucket actually. So B11 is the data bucket right now I have in my thinker.io platform. So what I will do, I will go to that platform and I will visualize my past data. So actually it is storing the data. So this is the data and with the timestamp, right? So this is available with it. Fine. So this is the data of 25th June. Okay. And before that, I deleted all the previous data. So right now, these are the historical data I have in my bucket. So you can have this data. And again, another important feature is that you can export the data as CSV value, or you can export it at JSON format. So all those are possible, and those things can be possible with your email also. So you can send the data to your email. Okay, whatever email you have given in your thinker.io platform, that is the data will be available in that platform. So this is the last export actually. So this is the last export file what I did. Okay, and on 16th June actually. So 10 days before data. Okay, so this is the data bucket, and we have to, you can get the historical data if you want to analyze it. Fine. And again, there is another important thing, that is the device. So we'll go to the device option, and again, that means the device, those are connected. So you can see ESP8266. This is the device right now connected with my thinker.io. Fine. So this is the device. So what I will do, I will click on this device right now, and okay, it will give you the live data. What is going on? Okay, and yeah, right now you can see the data. And it is the transmitted data size, so 703 bytes, and this is the live transmission. So the data is coming. You can visualize it through the device actually. So the data is flowing through. Okay, and some delay is there. That's why it is not continuous. And again, it will show you the location. So we are from Kolkata, so obviously it is showing you the Kolkata. And okay, another thing is there, some API. Okay, so for providing purpose, you need the API. So these are the things. And again, I have the LED. So if I will change it here, say right now it is on. Okay, and if I will change it to off, automatically it will be off. Okay, so what I'll do next, yeah, the DHT11 data it is now available in the device also. So lots of activities are there, and the time is short, I think. That's why I have to minimize it. And further, one of the most important parameter that you have to configure for third-party applications through thinker.io, that is the endpoints. So I have just modified 3 endpoints here. You can do as per your requirement. So I will click on one of them, and yes, this is available. So through this, what I can do, like these are the action you can do. So email, you can send the data through email. So the data will be available in your email from the Things network, and then virtual activity can be there. IFTTT webhook is also there, and this IFTTT is very much interesting actually. It can connect multiple cross-platform. Okay, that means if some activity is there in this thinker.io, depending on that, it can tweet something. So it can connect with the Twitter also. Fine. And again, it can connect with the, okay, if time is there, time will allow me, then I can show you the double IFTTT platform also. Okay, so how to do that one? So right now I will configure the email actually. So this is my one of the email that I can show you. Okay, so what I will do, this is the IFTTT and some custom, okay, with the data, and yeah, so tweet. So we have to enable it. Fine. So next, update the endpoint. So what it will do, after the certain interval, it will send the data to my mail ID, and I will request the participants if they can provide their email ID. Then I will put that email ID also here, and automatically they can have the live data also. Okay. So at the end of the day, if the participants want, then we can do that experiment also. That means they have to provide the email ID to me, and obviously I will put that one in the thinker.io here, and automatically after certain intervals they can have the live data. So that is also possible. And another thing is that using this we can modify and we can control various applications actually, web-based, online or offline, both. And like Twitter, suppose you want to tweet the temperature and humidity data from your home, so automatically you don't have to do anything, just configure the IFTTT, go there, create one applet, and you are good to go. Also another that is already open in my account, so I will just quickly show you the IFTTT platform. I think within 3:30 I will close. Okay, I will finish my lecture, so or session. Fine. So quickly I will go to the, so right now I will stop the thinker.io platform. Okay, fine. So what I will do, I will switch to the IFTTT, right? So fine. Yeah, this one. So yeah, you can visualize it. This is the IFTTT, and this is all. These all are free. Okay, free and open source. So this is the activity. These are the activity what we can do. So what we have to do, we have to create here. Go to the create option, and if that's why IFTTT. If this then that, okay. So that is the thing. That's why we are saying IFTTT. That's why the website name is IFTTT. Fine. So what is if? That is the webhook actually. So if you are familiar with the webhooks, then you can know it's actually for receiving the web request. So through webhooks, actually we will get the web request from the thinker.io. So click on this, then we will just say some event, say test IoT, say for suppose for create trigger, and then this. Okay, so what we can do, we can do Google, say Google Sheets also. So whatever data we are getting from thinker.io, we can plot that data in our Google Sheets also. So that is very much possible. Okay, very much possible. And we can do all these activities. We can connect with the Google services. Fine. And if we want to tweet something depending on the parameters, then okay, tweet is also available here. Yeah, sorry. This is Twitter. Okay, fine. So select Twitter and post a tweet and all those things. So lots of activities are available in IFTTT. So if you are interested, you can explore IFTTT, a very good website to integrate third-party applications. Okay, you don't have to do too much activity, right? So right now, this is the thing through which we can modify and data and okay, fine. So yeah, let's see the email, whether the email is available to us in our ID. So okay, I will stop presenting this one. So I will go to my email account actually to show you the email activity. Okay, so this is the inbox, and this is the weather data, thinker.io. So yes, this is the latest data I can, yeah, I have. So this is the thing. So right now I can have the latest temperature and humidity. Obviously the timestamp is there, right? So the data is available in my email. So if you want to configure your email and you want to receive the data in your email also, that means notification, some kind of notification if you want to receive, and then yes, you can do it. Okay, so lots of things are there to explore and do, but the time is very much limited because yeah, almost 1.5 hours. So I will stop here right now, and okay, over to the participants if they have any query, doubts. Okay. So this is all from my side. So again, I will request Balaram if participants have any query or anything. Okay, so these are the references for the part of that means the Firebase part. You can take help from this PI Bots Maker Hub, actually open source hardware community. Okay, and the resources, they have the resources. Okay, and that is available in GitHub also. Okay, for the Firebase controlled LED bulb. Okay, so these are the references I have. So right now, yeah, we can go to the question answer part. And if participants have any query, anything with them, I think they can. Okay, so this is the link. So you people can just ask me the question in this link also.
Well,
Okay.
Asim,
Yes.
here we have one question
Hello?
from. Am I audible,
Yeah.
Asim?
Yeah, audible.
Fine. Here we have one question from Mr. Debanjan De. He is asking, what is the
Yeah.
difference between Thinger.io and Firebase?
Yeah, actually, Firebase is a complete cloud database actually. Okay, so in case of and that is also not open source. Okay, so you have to pay, and certain features are not available. The features I have explored in Thinger.io, those features you can't configure in Firebase actually. Okay, that means for third-party integrations, we can't do so much activity in Firebase. Actually, it's a database, complete database, cloud database. And again, for database activity, don't choose the Thinger.io, because Thinger.io is not suitable for that. Okay, Thinger.io is suitable for what kind of application? Suppose you want to analyze your data, at the same time you want to control your data. Okay, that means for both the purpose, it is okay, fine, right? And there is no restrictions actually. So you can do as per your own. But in case of Firebase, it is not properly possible to have all the resources. Fine. For free account, some restrictions are there. So you have to choose depending on your requirements actually. Okay. I think any more doubt? Yeah. Okay. Yeah, actually, yeah, we will proceed to the next session. So, and right now I will hand over the session to to Mr. Krishnendu Chatterjee and Shobik Das. Actually, both of them are from BPPIMT, and they are second year students. Krishnendu from IT and Shobik is from electrical department. So they will give you a demonstration, okay, on home automation actually, but they will give you the server side demonstration. That means they will show you all the activities, but basically specifically the coding part. So without using any third party, that means commercial servers, actually how you can develop your own, how you can develop the server side code, that they will demonstrate actually. So right now I will hand over the session to Mr. Krishnendu Chatterjee. So Krishnendu, please switch on your mic and camera and start your session.
Hello, can you hear me?
Yeah, you are audible. Yeah.
Yes. Hello everyone, I'm Krishnendu Chatterjee and I will be presenting my PPT. Wait a minute. Is my PPT visible? Hello?
Yes, we can see it.
Okay. First of all, we'll just start demonstrating about our hands-on experience, that is our automation project. First of all, we have there can be two types of servers. One is public server and another is private server. In case of public server, the server is the cloud which is hosted on any platform like Heroku or AWS or Google Cloud Platform, as Sarah, which Sarah told before, and that can be accessible from any other devices like our client, NodeMCU, and others if required. So here, when the client sends request to the server, that is turn on the bulb, the server will get the request and server will send the request to the node MCU and the bulb will turn on. And like that same process, the bulb can be turned off also. And for the private server, everything is the same, but here the router cannot be accessible from the outside world unless it is port forwarded or a tunneling process takes place. Here, the same process actually works. The client side sends the request to the router, and the router sends the request to the node MCU, and the bulb is turned on or turned off. But here we can use it without router also, with the use of inbuilt node MCU, with the inbuilt node MCU hotspot. So same process, the bulb can be turned off without the help of the router. And now comes the ways of communicating to the server. There are multiple ways. First one is polling, second long polling, third WebSockets, fourth one is MQTT, fifth one is server sentiments. There are many other events, many other ways also, but these are the main ways. First, let's see what is polling. Here is the client side, that is an Android phone, and we have a server side, that is our public server. And first, we are sending the request, then the response is received to the client side, that is the switch is turned on, then the response that it have turned on, and after that the connection is closed. This is a simple HTTP request, and this request continues over a prolonged time. It's a continuous process. So this process is called polling. And after that we have long polling. It is same as polling, but here the response comes at a delay. Let's see. First the request is sent, then we have delay. The delay is because during polling we are sending continuous request and the server is updating the same response if the data is not changed in the database, but we are getting the same response and we are actually wasting the data by sending the request and getting the response of the same useless data. So by long polling, if we are giving a delay until and unless the value gets updated in the database, it will not send the response. So the wastage of data can be minimized in long polling, but it is still not a very good way, because here the connection initiating also takes place multiple times. Like after delay, the response is received and the connection is closed. So after that, again initiate the connection and again delay and again response and again connection close. So it is not the best way. And next we have WebSockets. It is one of the preferred ways. Like WhatsApp, it uses WebSocket to transfer messages. Here is the client side and the server side, and we are opening the connection between the client and server. Then using WebSocket, we can set unlimited messages from the server to the client and the client to the server. And the connection is not closed until a timeout occurs or until externally it is closed. So here the data usage is less, and there is it is on one of the fastest process also, because the main part is the connection is not open multiple times. And after WebSocket we have MQTT, which is the most preferred technique for IoT in case of IoT, there is the client side and the MQTT broker, and then server and node MCU. The MQTT broker is another server which takes the request and sends the response. Like it is just another server. We can use the Mosquito server, which is the MQTT server. So in case of MQTT, it is based on public subscribe process. Here we a user can subscribe to a particular topic, and whenever another user publishes a message to that topic, the ones who are subscribed will get the message. Like first we are publishing a message. Let's say the topic is fixed here, and the client side and server and the node MCU are getting the response. That is the subscribe message. That is the message, and at the same time. So, and it uses much less data, which is actually less than WebSocket also, and it is almost as fast as WebSocket. So the update takes instantly. So this is MQTT, and the next comes is server. It is fastest among, actually, because here it is not a both side connection, it is a unidirectional message. Here the message is sent only from server to the clients. That is the client side and the server side. First the connection is opened, then several responses to the client side. Like we have our notification. When we doesn't need to send message to the server for our notification. We get the notification whenever there is some message to our server, not from our side, from anyone else. So the server can push notification to us. So this can take place with WebSockets, with polling, with anything, but server sent event is the best way because it uses the least time actually, and it is the fastest among all. And in our home automation, we are using server sent event. So here are the basic requirements. There is the main hardware components are node MCU, relay board, jumper wires or any wires, and a bulb to test with. And the software part, we need Arduino IDE installed with the board manager of ESP8266 and the required libraries, and Arduino code which is written in Objective-C, and the server setup, hosting a real-time server or a microcontroller as a server, which I previously told. And we are here hosting our server in Heroku, which is free for a limited usage, and we can turn to a paid user by paying a minimum of $7, I guess, which has more benefits. So here we have our circuit. First it is a node MCU. Next we have the relay board. And first we are connecting VIN to the VIN of relay, and next the ground to the ground. Like we are showing entirely in our site table. Then the connection is D1, then D2, then D5, then D0. And after sending the response, the bulb can be turned on or turned off. Now we have the Arduino code. Now Shovik will explain the Arduino code. So,
hello everyone. Hello, I am audible. So now I will explain explain the codes. The following we have used, the following libraries we are using here is ESP8266 Wi-Fi.h, and we have used ESP86 SSC.h, which is written by us, and Arduino JSON is also being used because we are deserializing the Arduino JSON string, and the global parts are the in the code. The global parts are there. Hash include ESP8266.h, which is we are initializing the header files, and these are the header files we have used. And then we have defined the relay pins of pin number 4, 5, pin number 4, 5, 14, 16. These are the GPIO pin we are using in ESP8266. So we are taking the booleans of relay 1, relay 2, relay 3, relay 4, and we make it false. So if we are using 0 or maybe false, both are similar, and we have to initialize the Wi-Fi SSID and the passwords. So according to the user will define the SSID and password of their Wi-Fi. So after that we have to initiate the host name. So this is the bhavan.co.in, which we have hosted in Django. So after that the path is the extension which is we have used SSC/token. So token is the authentication token which we generate after user register in our server, and we provide them the authentication token. According to that, the code will be written. So after that we are going to use the Wi-Fi client, Wi-Fi SSC.client, and we are using the port 80. In the void setup, we have initiate the serial pin serial of 115200, and we are starting the serial client. After that, small delay of 10 millisecond, and after that we are initializing all the relay pins. So these are the pins which I have earlier explained, the pin number 4, 5, and 14, 16 pins. So after that, in the serial monitor, it will print. It is trying to connecting to SSID and password, and if it gets connected, this is a while checking is there. This while loop will check whether the Wi-Fi is connected to the router or not, and in this way it will print the dot in a delay of 500 millisecond. And after leaving a line, it will print the IP address, and it says the Wi-Fi is connected, and it will print the local IP address, which is the IP address provided by the router. And the host name will be also printed in the serial monitor, and the path and all things will be printed. And here the setups ends, and now the while loop begins. And in the while loop, we are using we have said that if in the while loop, it is continuously checking that it is the server is connected to the device is connected to the server or not. After checking, if it gets that it is connected to the server, then it will it stores a data from which it is getting from the server. Suppose a user is pressing a button on the app, and the data is transferred through the server, and after passing through the server, it will store data on the string data, string this data. And if the data is starting with if the data is not blank, this is this part is checking that the data is not blank, and after that that means some data is getting, and after that it will initiate that it will deserialize the coming data. And here I have to say that we are using deserialized JSON. For this reason, we have initiate the header file Arduino JSON.h, and after that the it is getting the S1 value. In the S1 value, if it is true or maybe false, it gets to the relay status, and if according to the relay status, it will turn on the relay. Maybe it is getting false, so the relay will be off, and if it is getting the true, then relay will be on. That means our appliances will turn on. And the same way we are doing for all the relays, all the 4 relays we have. So this is the code, and I think the loop is ending here. So after that, I have a video demonstration for you all, where I have which I have recorded before, and here I am explaining how the connections and here I am explaining the connections and all the things. Can you hear the audio? Okay, sir.
RTIC2020 based low density, a piece of breadboard, glass. You can also use some jumper wires. A USB cable, really a power supply. You can use this 5 volt power supply, or you can also power the board in this 5 volt electric circuit. So we can use this. If we are circuit board, we will go to how it works, and how we are going to connect this video board with our board. I have changed the board switch. The connection is only at the side.
According to this schematic, we have connected all the relay board with the Wi-Fi with the ESP8266. This is the code which I have explained till now. We have to select the right board.
Okay, sir. We will start from the first. Sir, will we start from the first?
Krishnendu, carry on.
Okay.
Here we have, I will take one wire so that it will get with this main source. So this is a 5 volt.
So here, if we are pressing the button on the app, we are getting the serial in the serial monitor. We are getting the JSON string. So here actually we have set all the connections, and we have uploaded the code which I have explained just earlier. And after that, in the app we are getting the we are having the buttons, and if we press the button, we can see the JSON strings are printed. As it is SSE, means server sent event, on the moment I am pressing the button on the on the app, on that moment the string is getting from the server, means Arduino ESP8266 is getting data from the server. This is the specification of server sent event.
Now I will show you how to connect it.
So I am connecting the
So that
all
the
project with the bulb.
bypass to the rig. Now I will connect the two wires with the presentable wire of the same case, so that it will get 220 volts directly from the buck point. I will take the extension cord like this. So here I have the 20 volt supply. So I will put the wires in the 20 volt.
So when we are pressing the button on the app, we can see the bulb is changing its state, and it is so instantly and fast. So you can see if we use other servers like Blink and other Firebase or other, this project is faster than that because we are using server sent event. So this is the specification of the. So so after all this, if you have any question, you can ask us. Hello, I am audible.
Yeah, audible.
So if you have any question, you can ask us. Any audience have any question, you can ask us.
Okay, so I will request to the participants if they have any query, then they can ask.
I have a question.
Okay.
Yes.
Achha, how does the data get lost in the that one of the servers that you mentioned, that I'm forgetting, that long looping or something, that
Where in here?
one of the first servers that you mentioned, that how the data gets transferred from the from a device to the server.
Polling or long polling?
Long polling, in the long polling.
Long
Correct.
polling, the data is not lost. I have said there is a delay. Means
delay. But later you mentioned there is a wastage of data. You have mentioned those words.
There is a wastage of data actually, because we are if the data, if the state of the switch is not changed, then also we are getting the same response, because it is continuously getting the HTTP request from the server. So we are getting the same response, and we are wasting. We are the wasting of the same data. Actually, we don't want, like in a day we are there 84600 seconds, and if we request the same data from the server, their wastage here their request of this many times, and most of the request will be wasted.
Okay, wastage in a sense that we don't want the repetition of the data.
Yes.
Oh,
the data is wasted also. If we use a broadband, then the database is fine. But if we use a limited data mobile network, then it is a very problematic actually.
Okay. Thank you.
Well, Krishnendu.
Yes, sir.
Someone called Mr. Kuntal Bhumik, he has a question. The question is it possible to design a PCB for smart home automation?
Yes, we have our PCB. If we can demonstrate also.
Sir, we have designed PCB for...
The question yet is not finished yet. With position for all the components in PCB.
Yes, sir. We have position. We have all the components are positioned on the.
We can show it right now. If I will request if to wait for few minutes few seconds till we can.
So I guess Kuntal got the answer. Thank you.
So,
Right.
sir, hello.
Yes, yes, you are audible.
Is our
Continue.
screen visible?
Sir, may I show the circuit we have for that?
Is our screen visible?
Hello.
Hello, you are visible. You are visible.
Yeah.
You are visible.
Okay, sir.
Okay, sir. Sir, this is the PCB we have. Here we place the ESP8266 12E, and here is a space of 4 relays. So here we can place all the 4 relays, and we have a place of IC. So like this. Sir, here we have placed the 4 relays, and we have to place the ESP826612B here, and we have a IC called LM316. LM316, and if you place the LM316, it will convert the 12 volt into 3.3 volt, which is supplied to the ESP8266, because ESP8266 consume 3.3 volt, and after that, if we upload the code here, and we can operate the home appliances through this relay.
Okay, I think the answer is complete. And okay, any further
And
query?
this is a full box. We have all thing in it.
Okay, so you have done a great job. Thank you.
Thank you, sir.
Thank you, sir.
Okay, so any further query we have from the participants? Right, okay.
Okay, sir. So we are closing.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir. We can present the can present the app, and also all thing
So we can present our website, how we have done, how we have made it user friendly or like that. How anyone can use our website.
Okay.
So we
So
can
you can-
explain how to register and
How
make their own project.
how it is operated.
Okay, okay. So yeah, show us the
Here
demo. No problem.
our website.
Okay.
Our website is bhavan.co.in. Is it visible?
Yes, it is visible.
Okay.
Continue.
First, I am logged in, so it is showing logged out.
Okay.
So let me first log out, and here is showing home and join. Then first we are joining. Maybe due to the network speed is less, that's why it is taking much time. Or maybe due to the Google Meets, it is consuming much data. It's taking much time. You can taking much time to load. Some network problem, I guess.
Sir, this is the website we have. So if we so here we have the website presenting here. So sir, if we log in or if we press login, sir, here any person can create their new account, and if he create new account or directly if he has his account, he can log in there. So here existing account is there. So if you log in here, so
Enter the wrong password.
so so here we have the falling switches and the dimmer we have. So we can operate the speed or maybe dim the light, and we can control the buttons through the buttons. And also if someone want to register here, they can use our app and our server. So here the person will fill the form, like first name, last name, email ID, username, country, and all the region, and he will create a password here and sign up here. So after that he will get all these buttons and and he will get a authentication token from us. We will mail them authentication token, and using that authentication token he have to put the authentication to the coding to the code, and after he puts the code there, in the code he can use the node MCU through internet.
So now actually we have demonstrated our previous server that is hosted on Python Anywhere. Actually, before we are hosting on, now we are hosting on Heroku, but as we are using a free plan, so there are some restrictions there. That's why our other server is not working. So we have shown our previous server, that is the Python Anywhere one, and that's all. Hello? Am
Okay,
I?
yeah, audible. You are audible. So the entire presentation is complete.
Yes, sir. Yes, sir.
Okay, fine. So if from the participants, if any queries are there, then okay, we will answer them, or otherwise we will close the session. So is there any query or doubts from the participants? They can post to them in the chat window.
Well, it seems
Okay.
no more questions. But
Okay, fine.
before closing today's session, yeah, announcement is there. This announcement is particularly for the students. Tomorrow you have a session. It will be an interactive one. Actually, he is a alumni of our college and our department. He will give you a lecture and a special session on IoT, and from that particular lecture and from his view, actually you will find your way to in the field of IoT. Okay, thank you. So thank you all for today. We will meet again tomorrow at sharp at 2 p.m. Thank you.
Thank you.